You must use balloon data. Radiosols carried in balloons.
Right, and so that's my whole point, is if this is your evidence that warming's not occurring, do you or do you not trust the balloon data? And then,
do I trust them?
Yeah, do you trust them as valid? Because you say that...
Look.
I mean, it just seems to be a little contradiction. You're basing your primary argument on data that you're claiming that you don't really trust.
Yes, I trust them.
Okay.
Because they've been published in peer-reviewed journals by the best people who know what they're doing, and there has been no objection.
Yeah, well, actually, then that was the follow-up question. I recently reviewed an abstract that stated that there was something, and I'm really not that familiar with this, that there was something called non-climate factors that bias the data-SON data in a negative direction, and they used something based on thermal wind equations to correct for that, and based on those equations that they did show warming in the atmosphere.
Oh my,
and again, that's not my area, so I'm asking you for your interpretation.
I can tell you something about that. It has to do with the fact that these two graphs, these are the crucial graphs. Again, this is what the greenhouse effect should be from the models, and this is what's observed. There's a clear disagreement. That disagreement is actually spelled out in the government report. And the question is, why haven't they drawn the right conclusion? The answer is they don't really want to draw this conclusion. The right conclusion is that the greenhouse effect is very, very small. You don't see it. You don't see the hot spot.
So then to answer my question, that those equations, the calculated temperature data are not accurate.
The way they've attacked it now is to say, well, maybe there's something wrong with the data. And in order to develop a different approach, Sherwood and Allen at Yale have tried to use the thermal wind equation to replace temperature data.
Right, that was what I was referring to. I was just asking how accurate.
In theory, that's okay. I'm very familiar with that. However, it's a very poor way of measuring temperature. It really doesn't work. So I've attacked that.
Okay.
We have a little dispute on that.
Yeah, I mean, it seems like there's a lot of dispute because they've essentially attacked the data-SON data, so it comes down to which, as far as my perspective, which one of you
believe me,
credible.
The other side is trying very, very hard to discredit the result that we have.
So go ahead. Your
They
question,
realize
then
that
yours
it's
here.
important.
First, I wanted to thank you for coming to Ohio State and facing this crowd. You're a very brave man, and we do appreciate what you've done. One thing I don't think we can, any of us would dispute is we've all seen inconvenient truth. And if you take a look at Al Gore's own chart, you'll see that he has a chart of CO2 and temperature going back 650,000 years. If you take a look at his chart, he shows CO2 reaching a record high of around 380 parts per million. If you look below it, though, you'll see his temperature chart. All previous peaks on his own temperature chart are substantially above the current temperature level. So doesn't Al Gore's own chart disprove this theory that CO2 drives temperatures, considering that we're at well above record highs according to his chart, and the temperatures are substantially below all previous peaks?
That may be so. We've not made use of this fact. We consider this fingerprint method the most reliable way of establishing the importance of the human influence. I agree that one can also argue from the past CO2 and temperature data and perhaps derive some information, but that's always tricky. Things are never the same. Ice conditions were different. Many things were different in the past. But it's a possibility.
You have a question?
Yeah, I was just wondering, given how complicated and complex the climate is, and that some scientists think there's no change occurring, some think there are, it's probably just a little bit difficult to tell. Maybe it would be better to be a little conservative and stop our massive deforestation and destruction of habitats and excessive consumption of energy, not just in case it might have an effect on the global climate, but there's a lot of other negative consequences as well.
Okay. Okay, so how about that? So,
I was relying on the chairman to
Yeah.
interpret every question.
yeah. So what she's asking is that since the climate system, as you said, is so complex, so why don't we be conservative and try to reduce our impact in the planet anyway, just in case it is truth that it is warming?
Yeah. Now, this is what's called the precautionary principle, and it's well known, but it has to be applied consistently. By this I mean there are many, many things that can affect us. The precautionary principle says, essentially, that we should take out an insurance policy. And so you always have to ask is, how much does the premium cost, and what is the risk? So the question to ask is, supposing it did warm as a result of CO2 increases, does that represent an important risk? Would you say that a warmer climate is worse than what we have today? That's the question you have to ask and answer. Let me put the question in a different way. What about a colder climate? Would you say that's better or worse than what we have today? Most people will say it's worse. Well, if a colder climate is worse, and if a warmer climate is worse, then logically it means that the present climate has to be optimum, the best of all possible climates. I think if you reflect on that, you'll see that that's very unlikely. If you go back into history, and we have actually good historical data, going back a couple thousand years, real records, you find that the warm periods in human history have always been better than the cold periods. It's been better for agriculture, and therefore people have lived better, they have lived longer lives, they have had more money, they were able to do more things. Life was good in the year, let's say, 1000, when the Vikings were able to settle in Greenland, grow crops, and they were able to produce wine in the north of England. And then we had the little ice age from about 1400 to 1800, when things were very bad. Crops failed, people starved, they got sick, they died at early ages. So generally speaking, a warmer climate is a better one for humanity, and probably for wildlife, and certainly for agriculture.
Any other questions? Yeah, go
I just
ahead.
have a quick remark. I have a few copies of this study that Dr. Singer mentioned, the study of surface temperature reliability. Price is Right, they're free if anyone would like one.
So I have a quick question. You said that you're a database person. You trust in the data.
Well, not always. But the models are clearly limited.
So what? But the data that we have, the recorded data, is only recent. It's only for the last 100, 150 years, the temperature record. So we have to look back and use proxies like the Delta O2 and other.
Yes.
So do you trust that data from corals and from tree rings and from bubbles in the ice and
With some reservations, yes. And so does everywhere else. I mean, geologists who work in this field, paleoclimatologists, obviously have to work with paleo data, with proxies.
So that data shows that carbon dioxide is very closely related to temperature. In the past, going back to
Yes.
So
When you say related to, you have to be very careful because it means there's a correlation. There's a strong correlation. That's true. But then you have to ask what is cause and what is effect. The detailed examination of the ice core records tell us that the temperature increase came first, followed by the CO2 increase. The difference was about 600 years. which means that the CO2 increase followed after the temperature increase, and it was probably caused by a release of CO2 from the ocean as the ocean warmed, like soda water.
So the greenhouse effect is not caused by CO2?
I think the greenhouse effect also exists and probably amplified the temperature increase. It's interesting that you mentioned that, because that is the paper I'm currently working on, hoping to present it here at Ohio State next month at the Conference on Abrupt Climate Change. So my hypothesis is, yes, that the temperature increase came first, released the CO2, but then the CO2 amplified the temperature increase by the greenhouse effect. And the question is, why is the temperature increase so strong during ice ages and so weak now during the Holocene? And the answer, I think, is that when the ocean is cold, it can hold more CO2. So it releases more CO2. Now, also, and that's a very important factor, the atmosphere was very dry during ice ages. Why? Because there was very little evaporation from the ocean, which means there was very little negative feedback from water vapor, which we have today. So I have a whole story worked out as to why we don't see these abrupt climate changes today that we saw during the ice ages, or that were seen during the ice ages. We didn't see them. They were seen.
Go ahead.
Fred, you mentioned that it wasn't worked out yet whether the water vapor was a positive or a negative feedback.
There's a dispute on that.
Is it not also true that one of the weakest links in all of the models is how they handle the energy transfer with clouds?
Yes. The models have a number of weaknesses. The major one, and that's agreed by everyone, is the way in which the models handle clouds. Clouds are very, very important. Clouds reflect sunlight, and therefore they control the amount of energy that can come to the surface. The models cannot handle clouds. The models make assumptions about clouds based on the judgment of the guy who builds the model. In fact, the reason models disagree with each other by large factors is because each investigator, each model builder, has different ideas of how to parameterize clouds. And that's not going to be improved very soon. They keep saying, well, if we only have models, have computers that work faster, we can have higher resolution. You see, the resolution right now is around 200 miles. Obviously, clouds are much smaller than that, so you can't resolve clouds. You have to make assumptions. The assumptions are tricky. Some people assume, let me give one example. It makes a huge amount of difference whether a cloud consists of a large number of little water droplets or whether it consists of a smaller number of larger droplets. How do you decide that? The answer is each investigator thinks he knows best. But it makes a huge difference in the amount of temperature that's produced. It makes a big difference in the amount of albedo, reflecting power. There are many other examples I could cite. There's a long literature on this. In other words, to sum up, clouds are probably the single most uncertain item about greenhouse models.
A question?
Yeah, is this on?
Yeah.
Okay. Fred, do any of the climate models account for the amazing specific heat anomalies, water vapor condensing to liquid and liquid water freezing to ice, and vice versa? There's over 600 calories per gram involved in melting ice and producing a vapor from 1 gram of water. until